Well, good afternoon. I'm Jeff Ralston with Ralston Eco Homes. We're on the site of our latest high performance build here in Swisher, Iowa. Swisher, Iowa is kind of midway between Cedar Rapids and Iowa City. It's a really nice location. I think people find it attractive for a lot of reasons. And so we're excited to start a new high performance build. Before we get too far, I wanted to shout out to Diana Wubin. She's an instructor at Kirkwood Community College. I had a chance to speak with her students yesterday. They're in the Sustainable Construction Science class. Mostly they're architectural students and draftsmen, but there are some people in the construction side of it, and it was kind of fun. We were talking about some of the things we're going to discuss here and over time. So sitting next to me is Mike Nolan. Mike, do you want to introduce yourself? Or?
Yeah, Mike Nolan. I'm the principal of Horizon Architecture. I'm an architect by training. I'm also a certified passive house consultant. I've been working with Jeff for a couple years on just kind of providing consultation and some ideas on a few of the other projects we've worked on. It was the first one where we've really jumped in and kind of been, I feel like, partners from the very beginning in the whole aspect, from getting the architectural plans together, getting the passive house portion done. So yeah, we've done a few passive houses in the state of Iowa. It's not something that's really taken off in the market yet, so we're excited to have this opportunity to work with something that's a little more hopefully approachable to a lot of folks and just kind of get the ideas out there. So.
The other person that's with us remotely, so this is a product of our times, is Lena. Lena is in New Jersey. She's been working very intimately on this project, and we've developed a nice relationship, I think.
I'm Lena. I've been working with Horizon Architecture as an architect for the past 3 or 4 years, and I've been working really closely with Jeff on this project to design the passive elements and do some research on how to make this constructible in the current market and make it approachable.
Yeah. So I think the first place I wanted to start it a little bit is put things in context. So Todd Richardson is the general contractor I've been working with, and we've done over a half a dozen what I would consider high performance buildings, single family homes over the last 4 or 5 years. And I know Todd has a lot of experience building to Energy Star standards. Most of his career he's done that, and he builds a very nice product. And we've built off of that experience over the years and have built to what is the Department of Energy Zero Energy Ready Home standard, which incorporates Energy Star, it incorporates Indoor Air Plus, Water Sense, and then it adds some other elements to the build. And so what we're doing at this location is building on that experience and taking it further. So I thought what we could do maybe first is just talk about what the standard we're building to is here, and then maybe Lena can describe for us after we just put it in context. Maybe Lena can describe for us what passive house history is and what that performance standard is. I don't know, Mike, if maybe you can just tell us, like, how does passive house fit in that? I think of it as almost like a staircase or a ladder maybe of where we started Energy Star, which I think is a great thing. If everybody was building to Energy Star standards, that would be a bonus. And then we've taken that one step up, maybe 2 steps, honestly, to Zero Energy Ready homes. And then now we're taking the next step. So what does the next step involve? I mean, what are we being asked to do that's a little different or more stringent, or what is it?
Sure. So I think you get a great introduction is that, kind of the basic home everybody thinks of that we would call like a code compliant home. And that's going to meet just the basic requirements for, some basic energy, some insulation, usually built to the International Residential Code. So a good house, but it's just kind of a baseline to start to. Energy Star increases on that by adding in things like more efficient windows, appliances, things along that line. But it's a compliance program is to be part of that. Builders have to be an Energy Star partner, and a lot of it is self-certification. So as long as they're saying that they're doing this, then they can kind of sign off on doing that. The Indoor Air Quality Plus and then the Water Sense are two other programs that kind of get layered on top of that address things like radon mitigation, some air infiltration, water quality management. And then you have the DOE Zero Energy Ready Home, which adds in another layer where you actually have verifiers come and look at certain portions of the build. There's a little bit higher standard for energy, for windows, things like that. So it's a more prescriptive approach. Passive House basically takes that next step on with the Zero Energy Ready. So it incorporates all those programs. So a Passive House is an Energy Star house. It's an Indoor Air Quality Plus certified house. It's a Water Sense certified house. It's a DOE Net Zero Ready home as well. Where Passive goes a little bit farther is that it's a climate specific. It introduces climate specific requirements, and it also has a much higher level of there's a prescriptive or a performance path to prove what you're going to do and to design the home. And then during construction, there's a more rigorous standard for verification, including looking at insulation at various different points. There's blower door testing to ensure air tightness and quality. And then there's also verification of the materials that you indicate you're going to do during the design phase are actually built. So there's a pre-certification process for design, and then there's actually a build certification.
That's one of the things that I've noticed that seems different right from the beginning is that while we were very careful about how we designed our previous builds and made sure that we were going to meet the requirements, this is pushing that back or forward. I don't know what the best way to say it is, but that design is being evaluated from the very beginning by a third party, for us that third party is PHIUS. But that's very rigorous. They're not going to let us get significantly down the path of building this house until we've been design certified. So that's been a big difference from the very beginning that I've noticed. One thing I thought we could talk about briefly maybe is you mentioned, I think even with the Zero Energy Ready home, there's kind of a performance versus prescriptive pathway, but that becomes those diverge quite a bit with Passive House. So PHIUS has both a prescriptive pathway and a performance pathway to meet certification. So maybe we can delve into that a little bit more.
Lena, I think you've been the training most recently, and I think that the prescriptive pathway is something that's relatively new. Do you want to tell us a little bit about how you're seeing the difference in those two pathways?
Yeah, one of the key parts that you mentioned was everything being very climate specific. And so right now, but the prescriptive pathway kind of puts a blanket over a certain area. So we're using climate data from the Cedar Rapids Airport, since that's the nearest location that we can get that from. And the prescriptive path is trying to use that climate data and find a way where we can have good insulation, good comfort, good indoor air quality specific to that climate. The performance pathway is more specific than that. You can talk about the orientation of your building, have shading from the trees and the landscape around your site, and integrate that into the energy model of your building instead of going through a checklist trying to mark off what we think would be best for this specific climate. PHIUS is getting better. They're getting a lot more climate data come in, and they're testing in different areas. So I think as the prescriptive path develops, we'll be able to get more site specific. But right now, the specificity is deviated between the performance and the prescriptive based on location. And there's only so much that we can do when we're looking at a larger area.
Do you want to talk a little bit about how that's developed over time from the first PHIUS, when it came from the Passive House Institute? Is that something did they talk about that in training?
So I've going way back in history. The passive principles are nothing new. So we're looking at solar orientation, shading, massing, trying to find a way to build a building without the help of electricity controlled air to make them comfortable for our occupants. And there are certain tolerances that came with that. But as a society, we're able to integrate conditioned air into our buildings and electricity and lighting. We ended up relying on that quite a bit. And it wasn't until around like the 80s, 1990s oil crisis, when we realized that electricity is expensive and it's actually a cost to the owners and the users of these buildings to run this conditioned air all the time. And so using passive principles from maybe vernacular architecture and trying to minimize the use of these new technologies and conditioned air, that's how the PHIUS Passive House Institute came to be, and that was developed in Germany. So I think there was a specific house that was Passive House certified, and from that became the Passive House Institute, where they created the standard in order to certify their own house. So the idea was that the standard would then be able to be replicated across different houses in the area, and it would use passive house principles, but it would not compromise on the comfort that we got from technologies and air conditioning and heating, so that we could have the best of both worlds, really. The passive house in the US, the main frontier woman for that is Katrin Klinenberg, and she studied in Berlin and brought those ideas back over to the US, specifically in Illinois, which is a pretty mild climate. I think they're climate zone 4 or 5. And so bringing some of those principles of air tightness, over insulation into the US, and also the idea of a standardized process so that that can then be multiplied and kind of expanded into the rest of the US. And since then, they've done a lot of research into different climate zones. So not only the standard 1 through 6 climate zone that we have in the international building code or the residential code, but specifying that down to the state level, and then even to just general, not quite city, but other levels. And so now PHIUS has been able to, through this iterative process of designing to the localized climate and using these principles, and with the third-party verification, they've been able to develop this standard and increase and improve on it. So originally they came out with their first set of standards, I think in 2015, and they've been improving on that. And so now we're using the PHIUS standard for 2024. And somewhere in between 2015 and 2024, they were able to get enough feedback from the performance pathway and these buildings that were using the performance pathway that they were getting the verification that that was working, that they could then channel it down and bring it into a prescriptive pathway that was more general to our area.
It's interesting when I listen to you two talk a bit about it. Boy, the performance pathway sounds like the way to go. Like to me, if I were somebody that had unlimited resources and time and wanted to have things, that I could be, manipulate a little bit to my own desires, the performance pathway sounds like the way to do it. So what is it about the performance pathway that's a barrier, or why would we pick a prescriptive pathway over a performance pathway?
I think the main barrier to the performance pathway is the soft cost. It takes quite a bit of time to do these energy modelings. We're already using BIM modeling, so we have a 3D model of this house, but in order to take that and put it into the energy modeling software and try and get every piece to line up, it takes a large amount of time and skills and a different skill set to do that. It's definitely possible, and you get a lot more leniency because you can push and pull very unique pieces of like maybe the window size or the thickness of your wall. Whereas in the prescriptive pathway, if you are able to follow a set of guidelines and check off all those boxes, then you should be able to meet the PHIUS requirements without going through the time and the soft cost of doing the energy model. And so there is a little bit of less leeway with the prescriptive path, but essentially it should have a quicker turnaround time because you're meeting these standards that are already set, and there's not any room or there's not a lot of argumentation of going back and forth or what ifs that are it's kind of eliminated from that process.
Right.
I think that, having gone through the early houses we designed used the full energy modeling process, and we ended up at the same conclusions, but it was a little more cumbersome. It took a little more time. So with the prescriptive pathway, it's created a little more user-friendly tool. It's still a pretty long spreadsheet you fill out, but by aggregating some of that data, it's given us a little more freedom and leeway, I think, to do what we have more conventional construction, which is typically what we're trying to do, is find ways to do things within the manners that are customary in a certain area. So that there's still trade-off of, you can still do the performance pathway. A lot of CPHCs, so the certified passive house consultants, are very familiar with that. So I think the training and the spin up over the last couple of years has been good. So there's more people who are familiar. So there are more options available. One thing that PHIUS, and just coming back from our conference recently, is the idea of scaling to go to more larger multifamily has kind of been the idea of how do we get the proliferation. So by making single family homes and smaller projects a little more approachable and cutting down the cost, that's something that we've talked about for years when they'd ask for feedback of like, hey, what are we doing? We're like, we're trying to do this, but it's just, we just can't bear the cost of a full architect and a full consultant on every project. So to the development of PHIUS, going from here's a very prescriptive pathway to how do we open this up to make it more approachable, and then making the tools more approachable, it's admirable to take the process where it is. And hopefully this is kind of that next iteration of, okay, now we're taking it away from just somebody who has, say very unlimited means of doing what they want with their home. How do we take these principles, which are just good principles everybody should have in their home, and make it more available to
the everyman's house? So that's right, and so that's part of what we're trying to accomplish on this project specifically, is two of those ideas. One is that we're trying to build a passive house, something that meets the passive house certification through the prescriptive pathway. And by getting through this process this time, it'll get easier and easier for us. And then the other thing we're trying to do is to use techniques that are kind of standard practice for this area, so that we're not asking our tradespeople to do things that seem outside of their normal scope. So the concrete guys aren't being asked to do anything that's really outside of what they normally do. The framers, the HVAC company, the plumbers, the roofer, we're going to meet this standard through a prescriptive pathway that should be reproducible and become standard for us. And then we're also using techniques that aren't outside the normal scope of practice. And so those are the kinds of things we're going to do here, so that it makes it more accessible to presumably almost any builder that wants to do it. That's kind of our objective here. So
I think it's interesting that some of the methods that when we look at different projects around the country, is there's a lot of different ways of getting the same deal done. So essentially, Lena hit on one of the principles of passive. We get there by over insulation, but the idea is having balanced loads. So I don't want to pull any more heat from the sun in than I can kick out. So what I'm trying to do is kind of mediate and keep a consistent indoor temperature, a consistent indoor air quality, and just keep that at a very high level. And when we first started doing these projects, we wouldn't be able to find a mechanical contractor that was familiar with an ERV, which is an energy recovery ventilator, which kind of brings fresh air into the house. But that's become much more common now. So the industry is coming along. So we're at a point where this is not totally unfamiliar. People aren't going to be living in, worried about a science experiment. It's just when they come into the home, they're going to see that, hey, it's not drafty. Hey, it feels good in here. Hey, there's a lot of natural light in here. Hey, I've got good indoor air quality. So things that they're really going to appreciate, and maybe they don't necessarily want to know every in and out of how it was built. And that's okay too.
Yeah, that's something we talked about a little bit earlier, is when we pulled up here, the house next to us is completed. And it looks like a nice home. I mean, it looks like the standard home in this development. It looks like what builders are building, and what we were kind of talking about is, I think when this house is done and you pull up to it, you'll see the same thing. Like it will feel from the exterior very similar. I mean, I think there will be some things that will stand out a bit, but for the most part, it's going to have the feel of that house. But now, and not to denigrate what they're doing next door, it's probably a very well built home, but I think this home will feel different to people when they live in it. You know, they will live in it. Some of it may not be as, you know, overtly conscious, but they will feel better in this home. And I think you struck on some of those ideas. So what is it when people are living in this house? I don't know if we captured it, but as we were filming, you know, a couple airplanes flew overhead. So we're very close to the Cedar Rapids, Iowa City airport. And so when people are in this home, what's gonna feel different to them?
So when we talk to clients that have now lived in passive houses, the big things that they come to is like it's just comfortable all the time. You may notice, like, if you walk through your home on a cold day, if you walk in front of a window, you may feel like that little chill. And that's going to be basically your body is radiating its heat towards that cold window. One of the, from a science standpoint, the windows in a passive house and all the surfaces are going to be within maybe 5 to 6 degrees of each other. So there's not going to be like that perceived cold spot in the house. So that just generally, it's not something you would notice, but it just, you may not notice the absence of discomfort. It just feels good. The sound, I think you hit on that, is that good air sealing, good quality, that's just naturally going to create a quieter environment. With particularly air quality is something that's becoming more and more. People are paying a lot more attention to it, as should be, by having filtered air, one is getting rid of pollutants in the house, so directly venting things like your bathrooms, your kitchen, getting that stuff out, getting those odors, getting those things away, and then bringing fresh air back in to replace that, like that balanced ventilation. I think that's another thing that people notice and do appreciate. And
yeah, I've thought about this quite a bit, but and I've come to different conclusions over time. But I used to think, there was a part of me always used to think indoor air quality was worse than outdoor air quality. Like we had to filter, the indoor air and then bring in fresh air from the outside. And maybe that's still true, but even here in Iowa, we've had days where the air quality outside is just terrible. And it's a combination of a lot of things, but some of it's wildfires in Canada. Some of it is, the farmer 2 miles away is spraying that day. And so, that's impacting your indoor air quality. So the way this house will behave is that regardless, indoor air quality, you're improving it by using a ventilation system that's bringing in fresh air that's being filtered, or that you're exhausting out the indoor air, or also if the outdoor air quality isn't as high a quality, then you're also filtering that.
Absolutely.
So I think you're getting both worlds, where we can make the indoor air quality better. Yeah, I think that's what we're trying to accomplish. And people, again, may not notice that potentially. They may live their life in this house and not particularly notice it. But, over time, especially people that have some sensitivity to respiratory issues, may find that their airways don't react the same way that they might in a normal home. Maybe they sleep better. Maybe we're not building up as much CO2 in their bedroom as we might have otherwise because we're exhausting that air out. Maybe they just are cognitively better in their home because we've exhausted some of those pollutants. So there's all kinds of things that the indoor air quality, and again, the indoor air quality isn't just ventilation. We're also using low volatile organic compound materials, so those are all being checked and verified from everything. The insulation, the cabinetry, the paint, everything is being inspected and checked.
Yeah, and that's a great point, and that's stuff that's incorporated under the Indoor Air Quality Plus program. So some of these co-requisite programs that we're working with.
Yeah. Okay. Great.
Yeah, I think from our standpoint, we're excited to see the opportunity to have a project that is more approachable and see some market integration. Some people look at an energy efficient house and they want to make it a statement piece. So when somebody drives up to it, they wants to scream, be it a large solar array or something along that line. What we're excited about is that, some people may not want to make that statement, but they still would appreciate the health benefits and the effects of having this. So we're really excited that there's an opportunity to do something that, I'm going to say is a little more mainstream, but, kind of looks like everything else out there. And I think that's what we're looking for, is a point where this just becomes the normal, where people are expecting this level of quality in their homes, expecting that they do have a safe and comfortable environment. And hopefully down the road, they'll also appreciate that they're going to save some money on their energy bills. And that's one, even the other part is people see swings in either much more for heat during the winter time, or more for cooling during the summertime. And another advantage of passive is kind of leveling out. So there's a lot of predictability to the energy bills. Are going to stay pretty consistent throughout the year once you kind of get settled into it. So.
Yeah, I think that's right. One of the things that PHIUS is trying to emphasize is resiliency, and I do think that can be useful, especially in our current situation. I mean, I do think we're seeing more extremes for weather. We had the derecho was a big wake-up call, I think, for people in this area. And so this house will also be more resilient. Now, this house will be set up in a way that people could have backup systems so their electricity never turns off and all that. But most people don't have that advantage. But this house will be more resilient to that kind of thing as well. So if the electricity goes off in this home, and it's 0 degrees out, it's a day later, you're not going to be freezing in your home. It may be 3, 5, 7, days down the road before it really gets uncomfortable. Yeah. And so the house is just going to be more resilient to those kinds of things. And I think PHIUS is trying to emphasize those things as well. The other thing I wanted to talk about just real briefly is that we're going to do more videos on this house. That's my objective, and they'll be shorter, and they'll just focus on specific things. Some of the things that we'll be doing in the home that I think will stand out compared to even a zero energy ready home maybe is first, actually the roof is going to be a fortified roof certified, so we'll kind of walk through that process. We're going to be using a very interesting ventilation recovery system that uses heat pumps, and I think that technology is really interesting, so we'll highlight that. The house is also going to have a smart meter. So Leviton has a smart meter with smart circuit breakers. So we'll be highlighting that aspect as well. And then one of the things we're doing to try and make it accessible to our builder or to our framer is we'll be using 2x8 construction. So it is some more lumber, but he'll be using the same techniques he's been using all along. So we'll try and highlight some of that. So stay tuned. I think there'll be more videos on some of the things that we're doing out here in Swisher, Iowa.
Excellent.
Yeah.
Thanks, Jeff.
Yeah, of course.
Appreciate it.